Hey guys, my name is Debes. Welcome to my channel. Today in this video, we are going to fine tune a pre-trained model with a custom dataset. Different scenarios we are going to discuss, like why fine tuning of pre-trained model is required, without fine tune, how it is performing, and after fine tune, how it is performing. So different scenarios we are going to cover in this video. Please stay with us till last end of this video. Hugging Face Transformer is a open. We are using Hugging Face Transformer, and it's an open source library for natural language processing that provides a wide range of pre-trained models and tokenizers. And this is developed on top of PyTorch and TensorFlow frameworks. And then in in our example, what we have taken is we have taken a model that is called T5 small. If you go to Hugging Face, there are many other models available like Google Flan, T5 XL and double XL and base. These are all large size models. We have not taken to train the large size models. The reason is, to training a large size model, it requires a huge amount of resource. So to avoid and to demonstrate, I have taken a T5 small model, which is also like trained with 170 millions of tokens, which is a good amount. And we have, why we need to require the training. The reason is, let's look at through the examples. Let's say I have taken T5 small model, and the tokenizers in this line of code, I am loading the tokenizer, loading the model. Then I have given a use case. This is the use case I am using: text to SQL. I am providing a text, and I'm expecting the model to provide me the SQL corresponding to my question. So what is the questions that I have put here? What is the ID and with name they base, and age equal 55. And I provided a context. I mean the table details, like the table is having like the column ID, name, age. These are the columns it's having. I'm expecting an answer kind of select ID which is equal to the base, where the age is 55, right? Or my age is 35. So let me change it. So if I'll run this, so let's see what exactly the result is coming. There is no training we have provided to T5 smaller model, and let's see what the response we are getting. And expecting because this is not, if you look at it, the response is, it's absolutely nowhere what exactly the response we are looking for. The actual response is nowhere, right? And then how do we get closer to that? The only answer to this is fine tuning this model with your context set of data set. So in order to train with the Hugging, like it's available. If you go to Hugging Face, there are many data sets available. I have choose one text to SQL, that wiki SQL data set. If you look at it, we have the data set we have provided. What is this question? What is the trace rows nationality? And the table of data, this is for training. So here the table headers, and it has data. And 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 this is the SQL. Like, we are training, like if this is the question to this sort of table with the context is provided, then we are expecting a SQL output of this, like select nationality from table where player is terrestrials, right? So, and then it, likewise it has immense, I mean huge amount of data set. If we will look at the data set, the structure, it is divided into three parts. So train, test, and validation. So if you look at it, the training part, it has larger data set, and the test part, it has smaller, much smaller than that, and the validation is the least one. so which helps in validating the training model. So it categorizes into these forms. If I look at it, a particular sample data set, so it will, like, let me just print out a first data set of the training data set that I have to use. So you can see that whatever the data set you see, we have loaded successfully, and it's printing that. So question is this, then your table is this, and your expected SQL output from that this model is we have provided into this data set. So, and how we are loading, and what is the way we can train a model. So let's look at it from the first line itself. So these are the imports that I have provided. From the transformer library, I have imports these classes: auto tokenizer, model for sequence to sequence, data collector, sequence to sequence, training argument, and these trainers. These training arguments and trainers I will show in the down, and this helps in training the model. So the first line what we did is load dataset wiki SQL. So if you go to this Hugging Face, so this is the dataset wiki SQL. You can just copy it and then provide it the wiki SQL over here. And then the next is I am loading T5 small. So this is the model that I am going to train today. And how we are going to train? So the specific input also need to be provided. So the data set, I have taken the question and the table schema, I joined it, and then my label of answer is the SQL statement. That is what I did here. The column merge is the tables, and the headers I have merged it. The question list is the questions, and the input is the question list and the columns, right, that I have merged. And the target is the SQL that is coming out of this model, so that is my target. And the model inputs, I use the tokenizers. So tokenizers, we have provided the inputs, the question, and the table structure. So this is my input to the tokenizer, and I am expecting the output from this model, and I will decode it using this tokenizer. So tokenizers, that is also another topic to understand. So we can create another video. So the tokenizers help in tokenization, encoding, padding, truncation, then decoding. So all these operations are done by or provided by tokenizer. And basically in high level, if I will understand, it converts uh, the data set into the smaller and machine, it's a numeric format. It will convert so that the machine will, or the model will able to understand and digest the trained data, and the same decoded the encoded data, when we the model will give us, and using this tokenizer we will decode it and we will get it. Okay, so first is as I shown in the below, like train, test, and validation. That is what exactly I am removing this column, and I'm making it ready. Pre-process this function, this functions gets called, and this model input, it's converting the data set into the tokenizer encoded format, and which we will be putting inside, passing inside the arguments. And that if I'll show you the trainer, right, this trainer, here I'm passing this model, and here the training data set, validation data sets, and the tokenizers and data collators. So using these arguments, it takes those data set and it started training. And these are the training arguments. I will touch base like each and every key elements what exactly is required. If we look at it, there is a huge amount of arguments that we can like configure. Each and everything is not possible to discuss, but there are some key arguments I have used here, like output directory. Here is the output directly, the results. You can see this, like the train model that has generated. Actually, it will generate with some checkpoint folders, so that you can use it. I have generated train this model, and I have uploaded this one to for the demonstration. And what I am telling is evaluation steps. Every thousand of records after training, you should evaluate that. And it does evaluation after 100 set of record it trains, it does evaluate. And the learning rate, this 5 exponential minus 6, it comes around like 10 to the power 1 minus 6, which will come like, it's a very small figure, it will come like something like this value it will come. So what it tells is, the the lesser the uh, training rate or the learning rate we configure, the better output we will get it. So the reason is, it needs to, already this model is trained, so it has to be trained with the new data set. So it has to be, the learning rate, it has to be configured with small amount of rate. Okay. And it has batch size and accumulation steps, warm up ratio. So, and this epochs, around 10 to 15 epochs. Epoch is a batch size of training, which will helps the, if it is 10 or 15, then it like your accuracy level will be good, your validation loss will slowly decrease. So this is a good figure to, like train it. So, and eval loss, these are the arguments that I have used, and which I find it in many like blogs or Hugging Face website. I find this, all these arguments required to be put in order to get the better output. So this is what I have used. And if you can see, I have trained this model as I am using Google Colab. So it doesn't have, it has, like GPU with a specific amount of GPU, one GPU only it get provided, and it's not very consistent. So if you are going for, like I will discuss in a little bit after some time, that how we can leverage the EC2 and what are the different EC2 instances are available in AWS that you can use to make the training faster. So it took me around like 1 hour 32 minutes. So I get like, I'm able to train it, and I get a good amount of epochs like 9 out of 10. And I'm able to, train the model. And then if you see, the training loss slowly gets down, right? And the validation loss also slowly get down. The more and more and you train, your training loss will near to zeros. That means, which will tell you that your training is proper, right? I mean, your accuracy is getting closer. So if you look at it, the validation loss and trailing loss is getting lesser. The more you train, the value will be get lesser. So what output I received from this, you can look at the screen. So in my without training, if you look at it at T5 small, it did not give me anything closer. It was not at all closer to the output. But in this case, I was getting like select ID from table where name equals to this, and age is 25 depending on the questions. Okay. So I have uploaded this trained model into the Hugging Face. So this is the name it will be available. If I will go to this uh, and search it into models, and I will search it, so probably I will get it. So this is the model, this is my name Devesh Sahu, and this is the fine tuned model that I have created and I trained, and that I have uploaded to Hugging Face. If you want to use it, so you can, this is the code as snippet I have already provided. If you use that, we can see like I gave one questions, what is the ID and address with name Devesh, is equals to 35. Then I gave ID and the column, these are the table data I gave. And I'm able to get the select ID and address from table, name equal to Devesh and A is equal to 35. More precise output I get it from this fine-tuned model. So what we learn from here is, a base model, depending uh, without fine tune a specific to a particular scenario and particular a domain pattern, if we don't train it, the result will not be that accurate. Once we train it, the result will get finer and finer, and this is the way how we can train a model. The the model also I have uploaded. I will give this collab link. You can copy paste this code and do the practice. So I know this is the starting step. So but this will help in the organizations not look for uh, bigger the models like GPT. If I look at it, the carbon footprint of those bigger models, day by day, it is increasing like insane. If you look at it, your OpenAI is GPT-3 is 175 billion tokens it is trained. And if you look for the carbon footprint of this, for GPT-3, 552 tons of emissions that is providing. There are many other large models are there. So the the models will get bigger and trained bigger. It requires more and more uh, like energy to train again. But if you pick a smaller model, you can very easily, providing with your set of context data, you will be able to achieve what we are looking for your business. And and it I believe this is a huge potential in future, where OpenAI is not free, and it's never going to be free. It charges depending on the token, the amount of strings you pass, and the amount of response it gives. And the day by day it goes, every AI trainer, all these models is going to be costly. The GPU amount the GPU is getting costlier, and all these models is going to be costlier in future. So the goal is to identify the smaller set of model, and how you train those models to get the accurate results. So I forgot to mention whether I explain about this T5 small. So this is a text to text transformer uh, transformer model, where it helps text to text transfer. Models are used for text classification, text generation, text summarizations, machine translations, language generations. So character I mean sorry chatbot systems. So this text to sequels that we are looking for, let's say we created a chatbot, they provide the input, and they are looking for some data, and you able to interpret into a particular SQL and get the output from the SQL and provide the user. So multiple use case this test to SQLs it is having. In one of the examples, you can train with many other use case that you can think of. And if at all you are not able to train, because this collab is not very stable in order to training those models, you can go for, if you are a beginner, I will suggest you to go for EC2 G4DN instances, which these are the compute. You can see like it has G4DN X large and 4X large. So this amount of GPU memories they are providing. And if you want to go for a large 12x large or metal, so definitely the price will go higher. So this is the price of those models per hour, like $7, or per hour $4. If you are a beginner, I will go for, I'll tell you to go and get started with 4x large. And then you can like train your model and see the output, and this will help you a lot. Do let me know, and like and share and subscribe to my channel, and let me know how it the video, do you like it or not, and provide your comment. Like if you any other video that we are looking for from my end, then I will definitely love to do that. Thank you so much.